So today I hope to provide you with all an overview of a number of key areas in regards to the subject of field BIM. Firstly, I'll be taking a quick look at where we can extend BIM workflows to the field, and in doing this I'll be looking at the current adoption of technology in the field, the gap in current project workflows and how the use of field technology may address issues in this area, what the concept of field BIM is, and what are some immediate opportunities that are available to adopt field BIM during construction. Then I'd like to share my experience with you on one solution that I've been involved with over the last couple of years, Autodesk BIM 360 Field, or what was known as formerly Vela Systems, and how it can be used to support field BIM workflows on site. So let's begin by setting the landscape for the use of technology in construction. It doesn't matter what type of project it is, it's all constructed in the field. According to the Construction Industry Institute, 25 cents of each project dollar spent is wasted in the field. Despite that 75% of all construction dollars are spent in the field, there are a number of key factors that contribute to this wastage. Firstly, that there is no or little technology applied in the field. We tend to resort to paper-based workflows during construction, which often lead to a loss of information, delays in communication, and wasted time and effort. The current IT tools that we use are traditionally used to create paper-based outputs. If we look at our design and CAD technologies today, they always lead to printed documentation. This creates a fragmented and interoperable workflow. Thirdly, our current manual process leads to project inefficiency, where significant time is being wasted on non-value-adding activities. This includes time and quality problems, rework, wasted overheads with long time delay between trades and safety incidents. Out of all technology spent on a project, 90% is being spent in the design and project office. It is estimated that only 0.5% of contract volume is spent in R&D in the construction industry as a whole. To me, this is an unbalance. This unbalance plays a contributing factor to inefficiencies and the wastage outlined earlier. So if we have a quick look at the project life cycle, we can honestly say that the use of technology and adoption of BIM have demonstrated great value and proven return on investment on projects through planning to pre-construction phases. The industry now acknowledges that there is a growing trend and push to extend these workflows into facility management. This is driving the search for technologies and strategies that allow us to execute this and provide an FM deliverable on projects. As Rob mentioned earlier, this trend has been driven in the market through client and government mandates, both locally and internationally, as well as companies like most of us here, for the push for innovation to be more competitive and provide better offerings to our clients. We can see that with these demands have driven us to focus on innovation with technology, especially in the design, pre-construction and FM phases, yet the technology in field has lagged. And what I see is created a gap between virtual design and physical delivery. The divide between office and field reduces the speed of quality of communication for construction and BIM-related information. The rich data set that we offer generate and collect on the job site can often be hard to collect and collate and incorporate into our BIM workflows for ongoing operations and management. This is something that hopefully the adoption of field BIM can help us address. If we look at the concept of field BIM, there are a number of key characteristics that help define what it is and how it can be adopted. This includes extending BIM workflows to site. This involves supporting both 2D and 3D workflows, focusing on, firstly, better and more accurate bidirectional communication of design and construction-related information between the office and the field. Also, bidirectional workflows that allow us to use the model to support construction whilst also integrate with it to support commissioning and handover workflows. Secondly, the virtualisation of data through changing what may have been completed in a paper-based format prior and moving it into a digital environment. This may be from just managing the delivery of drawings to the capturing of commissioning-related data. Part of changing old processes is to think more innovatively. When delivering 2D plans, why not deliver the model to site? Thirdly, mobile technologies. Using and leveraging the latest technologies to provide a better field data management tool, or FDMT as I like to abbreviate, with increased user experience and capacity. There may be a lot of Apple lovers or haters in the room, but without the invention of the iPad, since the invention of the iPad, it's promoted an industry to deliver more cost-effective and practical mobile solutions that we can deliver and use in the field today. Also, by providing an infrastructure that supports a collaborative environment for field data management tools, we've seen a growing adoption in the provision of cloud services amongst a lot of the vendors out there today, and these cloud services are enabling us to achieve this at a quicker rate. In adopting and implementing field BIM workflows, there are a number of key opportunities for us to improve efficiencies and productivity. Firstly, improve communication. Through ensuring that site teams that have access to the latest document and information at all times, we can implement field BIM to address this opportunity. We can also improve communication through implementing better workflows for managing issues, defects that lead to streamlined notifications and quicker resolution times, as well as greater exposure to the real issues on projects. Secondly, better project management. We can look to utilise field BIM to focus on the implementation of quality, commissioning and safety management programs that work towards a proactive measure to reduce the number of issues on site, as opposed to a reactive plan to address them. We can also use field BIM to reduce time delays and labour wastage by accurately tracking equipment, which I'll hopefully show you a little bit later, through the supply chain as it's been installed and commissioned on site. And thirdly, project delivery. We can use field BIM to improve commissioning and handover workflows to ensure that all relevant information is captured at the point of construction. We can also use this whilst also implementing strategies to ensure that the information is meaningful and can be fully integrated into a facility management system at handover. So I'd like to now move on to a quick overview of one of these technologies, and as I mentioned earlier, my experience lies within BIM 360 field, or formerly known as Vela Systems. And I'll show you some of the functionality of this solution, and I'd like to show how this solution may be used to address some of the opportunities presented before. For those that don't know, BIM 360 Field is a cloud-based field management solution that Autodesk recently acquired of June last year. I guess to support their strategies in delivery of this information to the field, they deliver this as a cloud service which enables users to access the live information as it is captured in the field, regardless of whether they're located, whether it be out on the job site or whether it be in the project office. In terms of how, with all the live information that's stored on the cloud servers, users have the ability to capture, access and analyse this information through any web browser and the mobile device. This functionality is delivered with the tools provided by BIM 360 Field web reports and mobile versions. For companies that are working on BIM projects and want to use the model to improve workflows, BIM 360 Field also provides the capability to take your Navisworks and or Revit models to site and integrate it with your field processes for bi-directional exchange of information. My experience in the past couple of years has been best to use Navisworks and or Revit models. Typically Navisworks because of the ability that it has to be able to support any file format that the industry uses today. Today I'm going to cover a number of key features that BIM 360 Field provides to support the delivery and execution of quality and safety programs, document access and commissioning, and handover workflows. When I go through some of these functionalities, you'll also see some key applications that are used to deliver these features, including the web, reporting and mobile versions, as well as the Field BIM model access on the device. So let's begin with BIM 360 Field's functionality for providing access to construction documents. Using the Field File Importer, we have the ability to upload and synchronise documentation from a local hard drive, server location, or files contained within a document management system to make them available for use on a project within BIM 360 Field. Once the files uploaded or synchronised is finished, these files will be made available on the project within BIM 360 Field Web for users on the project team to access and view on their local desktop at any time. Once available on BIM 360 Field Web, users will have the ability to download or update the latest versions of these documents on BIM 360 Field Mobile, whether they be 2D plans or equipment specifications to use offline when on site to support field-based workflows. This information can also be used in some of the other functionalities that I'll go through in a second as well. The BIM 360 the BIM 360 Field mobile and web versions also help provide better workflows around capturing, communicating and managing issues and defects. On BIM 360 Field Mobile, whilst in the field, we can effectively capture the locations of issues and defects through the use of locations and push pins on drawings that I showed how we uploaded earlier, as well as information and details surrounding the issue, as well as any associated photographs and or attachments that may help identify the issue, as well as actioning who needs to resolve these issues and by when, so it can be effectively communicated back to the project team. As the user in the field captures this information, it can be synchronised back to the project on BIM 360 Field Web so that other users on the project can review and access these issues and defects, as well as manage these issues through associated workflows. Within BIM 360 Field, this information can also be better communicated with the extended project team. As we see here, issues that are assigned to subcontractors within the sub-portal on BIM 360 Field Web allows them to review their assigned issues, access the information as it is captured in the field, produce reports to take to the field for action, and to communicate back to the project team once issues have been identified and or resolved. Using the cloud service provided by BIM 360 Field Web enables quicker communication of these issues as they resolve, so they can be managed for closeout more efficiently by project managers and teams on site. We can also use both web and mobile versions to support the implementation of quality, safety and commissioning programs. To support these programs, we can allocate checklists to users in the field to complete as part of their daily and or task inspections. When and as users review and complete these checklists, any observation that may lead to non-conformance and or issues on site can be managed through issue workflows to be addressed, thus supporting preventative management strategies to reduce the number and impact that these issues may have on project. As these checklists are synchronised with the project, management can access checklists within BIM 360 Field Web to ensure, to review and audit the data captured from the teams on site, as well as being able to manage any issues that are raised during the completion of checklists to ensure that they're resolved with minimal disruption to the project, as well as being able to close out the checklist and publish for archiving and internal record keeping. With the data that is captured through these checklists, it enables management to monitor the conformance rates of these checklists to track the performance of how these programs are performing on the project. The equipment tool within BIM 360 Field enables site teams to accurately track pieces of equipment through the use of barcodes and or equipment lists, and capture any required task-based information that may support project teams in tracking project performance. The ability to capture this information on site provides us with the opportunity to be able to holistically track the live project progress of material and equipment from when it is shipped to it is installed on site. If you're also using Navisworks or Revit, these models can be uploaded and used on the device for the interrogation and capturing of task and or equipment-based information. When the equipment data is synchronised with BIM 360 Field Web, project managers can get live updates as to the status of overall equipment on the project, as well as being able to interrogate specific items to track status and location. The data that is captured within BIM 360 Field in relation to the equipment can also be extracted out into detailed and or even more summarised reports. These reports can also be scheduled and sent out to specific users on the project to provide updates on project status. If you also integrating this system with the Navisworks and or Revit models, you have the ability to use this information in the model to provide colour-coded status summaries to support project review and planning meetings. With all this data centralised in a central cloud, it provides a central portal of live project information, which provides greater visibility on how projects are performing. Within BIM 360 Field Web, there are a range of reporting options that allow us to obtain visibility on a project or across projects through the use of the project dashboards, detailed reports in around checklists, issues and equipment, and or even these type of reports for cross-project analytics, all of which can be saved, scheduled and sent to project stakeholders, ensuring effective communication amongst the project team. This also enables businesses to implement avoidance strategies earlier to overcome any major issues that may lead to greater project delays. As shown earlier with the equipment tracking workflow, BIM 360 Field also enables users out in the field to be able to navigate through equipment lists or through the use of barcodes and select required equipment to conduct commission activities. As mentioned before, if Navisworks or Revit models are being used and integrated with, users can cross-check these items within the model on the mobile device to ensure they're commissioning the right piece of equipment. Once the equipment has been selected, users on site can collect any required data through installation and commission phases as required for ongoing facility management. This data may also include results from commissioning checklists, inspections, commission issues in relation to the equipment, as well as any associated documentation for the asset. When this data is synchronised with BIM 360 Field Web, it provides essential storage for all commissioning-related data. This enables other project members to view commissioning data as it is captured in the field, as well as the historical audit of changes to the data through the commissioning workflow. As a means of capturing the right information for ongoing facility management, BIM 360 Field also supports KV2 standards as a way of ensuring that the required information is collected for ongoing operations and management. To support the delivery as an as-built building information model, BIM 360 Field also supports bi-directional exchange of information back to Navisworks and or Revit applications. This allows us to take the related information and associated documents that are captured during the commissioning program whilst on site and have this integrated back into the model for delivery and handover for integration into facility management applications. So I'd like to finish up with a quick look on how the use of field data management tools like BIM 360 Field has driven efficiency on projects. Looking at a study conducted by Skanska, USA, across a study of 15 projects in the US, it was proven that they returned a 16% efficiency gain across all users on the various projects. That equated to anywhere between 6 to 10 hours of time saving per person per project. If we look at one of these projects in particular, the use of field data management tools for the management of quality, safety and commissioning programs, they were able to achieve 102% return on investment, whilst also being able to deliver a digital model for ongoing facilities management. With some of the functionality shown today and some of the results seen on these projects, we can see some immediate benefits for the adoption of field BIM and the technologies out there in the industry today and how it can be used on projects. Appreciate your time and hope you enjoy the rest of your conference.